So lecture 13 is on limit superior and limit inferior. And this is going to be much shorter than usual. So here's the definition. Is real sequence, the limit superior is limsup of an. It's defined by the limit as n goes to infinity of the supremum of the, the part of the range that is beyond n. And likewise, limit inferior is the liminf of an, which is the limit as n goes to infinity of the infimum of the part of the range which is beyond n. So you could write that a little bit more sort of, with dot 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 notation. Maybe that would give you better intuition for what's going on here. Limsup is like you take the supremum of beyond n, and then the n go to infinity. That's the limsup, and liminf is you take the inf of just beyond n in the sequence and let that n go to infinity. That's the liminf. Kind of sneaky. And so your textbook's okay. I mean, great. It has got standard results, but I couldn't get into it, guys. I mean, I thought we were going to cover this section, but it was missing the things that I thought were interesting about this. And so I took a look back at, this book here, Principles of Mathematical Analysis by Rudin. I think that's sometimes affectionately called Baby Rudin by certain folks. But anyway, in there, these results are given that use limsup. So in particular, the ratio theory, the root test is written in terms of limsup. The ratio test is written in terms of limsup, and the power series convergence is given by the limsup of the nth root of the absolute values of the coefficients of the power series. So all three of these results have in common the fact that they're part of the study of series. And unfortunately, there just really isn't anything on series in this current text we're looking at. And so I feel kind of out of place to really, I just don't feel led to cover limsup and liminf here without this stuff. Like, if I don't have this to apply, then to me, it takes the joy out of it for me personally. So we're this is what I got to tell you about it. Again, limit superior is important because of these reasons, but they're not in your textbook, so that's kind of all. I'm going to have to kind of leave it there. All right, guys, so thanks. I think I have written a problem on series somewhere in your homework, so at least we'll do a little bit on it, but not as much as I might like to in a different semester. So thanks.